السلام عليكم ورحمة الله وبركاته أسعد الله. اليوم إن شاء الله مكملين معاكم بسكشن 16.8 واليوم حنحل أول سؤال في هذا السكشن واللي هو بيحكي عن معادلات اللي بيظهر فيها مركب كاريولس. So here we have root AB. Where is root AB? Here it is. Root AB. Rotate clockwise. So here is the rotation clockwise. Omega is given. Such that it has an angular velocity omega AB is equal to 3 rad per second. This is clockwise, and an angular acceleration alpha AB 4 rad per second square. So alpha and omega, they are rotating the same direction. When theta is equal to 45, so theta again is given. Determine the angular motion of rod DE. So DE, we need to find the angular motion. And the meaning of angular motion means that we need to find omega and we need to find alpha at this instance. So we need to find omega and alpha at this instance when phi is equal to 45 degrees. The color at C, this slider, okay, is been connected to AB and slides freely along DE. So هذه المعلومة مش دائما بتعطى لكم. Okay, ولكن you need to make sure that you understand it. So here you can tell easily that this cooler is being connected to AB and rotate with link AB. And on the link DE, it slides on the link DE. Okay, so this information usually we will not give this information. Okay, so you should make sure that you understand. Okay, so this type of problem, this mechanism, is one of the mechanisms that the Coriolis component will appear. Why? Because the slider will has two motion. The first motion is rotation with link AB, and the second motion is sliding on link D. And usually the link that the slider is sliding on it is where we apply the equation of section 16.8. Okay, so equation of 16.8 is applicable for the link where the slider slides in. Okay, so link DE, for example, will apply equation 16.8. What about link AB? AB will apply equation of section 16.7. Okay, so again, if the slider being connected to a link, then this link we can apply the equation of section 16.7. Now, if the slider slides on another link, then we'll apply the equation of section 16.8. And let us take a look to the datasheet equation. Okay, here it is. Before starting chapter 22, okay, we stopped last time in here. So let me take this pen. We stop here. Okay, and then we jump over this portion to chapter 22. So this portion represents the section 16.8. So this is 16.8. Okay, and here is the velocity equation. So up to here. So this is the extra component here in this equation. So if we erase it, then we go back to section 16.7. For the acceleration, this is the new component, and here is the second component. Okay, this is the Coriolis as we mentioned. This one is carilless. Okay, and this is the relative acceleration of the primary with the secondary coordinate system. Okay, so here is the equations. So this is the position equation for the length where the slider is sliding on it, which is length dc or de. Okay, and here is the velocity equation, and here is the acceleration equation, and you can tell easily that this is the extra components. Okay, and this equation applicable only for length de or dc. Okay, let's now move to the solving board. Here's the solving board. And let me first start with writing the given information. Okay, so actually the total length of the pipe is not important to us. Why? Because we are looking until we reach the point where the slider is located. So here is the slider, okay, and it is been connected with the link AB. So here is A. B is the other end. This point on the slider is called C, okay, and this is D. So the extra length of the two links is not important, okay. And regarding the lengths, this length is 0.4. This is 0.4, okay, and this length is 0.4. Okay. And the angle here is theta equal 45 degree. And here we have given information that omega and alpha is given, where omega is equal to 3 and alpha is equal to 4 rad per second square. Okay, so that's all information. Uh, we need to find alpha. So if this is rotated in this direction, maybe this one will rotate in the same direction. Okay, so we need to find alpha and omega. Or once some of you will come and ask, use other symbols. We need to find omega, and we need to find omega delta. So this symbol same as omega, and this symbol same as alpha. Okay. Now, as usual, we used to start from the most given information link. But before, let me go back to these two equations and let us ask ourselves, where is the unknown? So here is the first unknown. We need to find alpha, as we mentioned. So this is unknown. And we need to find omega. This is another unknown. So it's mentioned in the problem, determine the angular motion. So the angular motion, as we mentioned, we need to find omega, and we need to find omega dot, which is alpha. And here is the omega. Okay, so we have two equations with two unknowns. Now, let us ask ourselves another question. So this is link DC, this link, okay, and you know very well that the point D has 0 velocity and 0 acceleration. So this acceleration will vanish out, okay, so it's equal to 0. Now, point C on the slider, it has acceleration and velocity. So we have here another unknown. This is again unknown. Okay, so how many unknown? 4. Another thing we have here, this is unknown. We have nothing about this one, so this is unknown. And this one again is unknown. So how many equations? how many unknowns? 6 unknowns. And how many equations? Actually, we have, they are 2, okay? But you know very well that every one of them is divided into 2 equations. So we have I equation and J equation. And here the same. We have I equation and we have J equation. So how many unknowns in total? We have 6 unknowns with 4 equations. So we have 2 extra unknowns, AC, BC. Now these 2 unknowns, we can get it from the link AC. Okay, so this extra link is not needed. Okay, this also is not needed. We'll work until this one. Okay, so these 2 extra unknown will find it from the knowledge of, because we know everything about this link. Everything is given. So we'll start from this link, from the most given information link. Okay, find these 2 unknowns and then moving to link DC. Okay, we are moving then to link DC. We'll have 4 equations with 4 unknowns. Then the problem will be solved. Okay. Okay. So as we agreed on, let's start with the link AC. Okay. So link A. I'll not use C. I'll use B. Okay, but I will draw this link until I reach point C. So here is A and here is C. Okay, so this length is given, which is 0.4, and this length is given, which is again 0.4, and this angle is 45. What else? Alpha and omega is given. So omega is equal to 3 rad per second, and 3, and alpha is equal to 4 rad per second. Okay, so let's start as usual with the velocity equation. So the velocity equation says that Vc, okay, since the slider is pin connected, then we'll benefit from equation of section 16.7. So this is Vc equal Va plus omega of this length, link AC cross product R C with respect to A. Okay, so Va is 0 because pin connected. Now Vc, and you know very well how to find the direction of Vc. So let me show to you here. So yeah, I will only erase this one here. So if this is rotated like this, then the VC's direction will be in this direction. So we'll expect that we'll have VC in this direction, X, and VC in Y direction. So we have positive quantity and in the X direction, and we'll expect that we have VC Y in the negative Y axis. Now something else very important before start solving is to locate the primary and secondary XY coordinate system. Okay, so the best thing to do, and in order to make this assumption valid, actually, okay, is to locate each coordinate system, the primary and secondary, coincides on each other. So they must be identical. And here is the same. This is the X capital, and here is the X lowercase. So this is the point where the both coordinate system starts. And the most important thing is to make those links uh, flow with the link. What do I mean? So in this scenario, this is the link where the slider slides on. So we'll pick this link and we'll pick its orientation as well, which will affect the coordinate system. So the x-axis will flow with this link and the y-axis is perpendicular on it. Okay. You do not understand? Let us see another example. This one, for example. So we'll come to it actually, but in order to explain what do I mean. So the slider slides on which link? DC or AB? Of course, it will slide on link AB. So I need to choose the location of coordinate system. So I will choose x-axis to be flow with the AB, primary and the secondary. Okay, and here is the y-axis. Why we'll do this? Because we'll minimize the number uh, of substituting the cosine and sine of of the angle given in the problem. Okay, so if we keep it like this, for example, we'll face a lot of trouble. Okay, we'll see in the coming scenario. Let's now stick to this problem, and this is why we choose the coordinate system look like this. So our selection is based on the location of the link where the slider slides on it. Okay. Okay. Let me go back to the solving board. So here is the problem. So VC is equal to omega C. Now the because we choose x coordinate system like this. So here is the positive direction x, and this is positive direction y. And as we used to do, this is the positive direction, which is counterclockwise. Okay, you can choose it clockwise, so not big deal. Now, so omega AC is clockwise, so this is minus, and its value is 3 in k direction, cross product. Now, in order to move from A to C, we need to move in positive x direction, which is 0.4 I, 0.4 in the I direction, and then we'll travel in the positive y direction, so positive 0.4 j. And the answer is, so we have minus sign, so minus k multiplied by I, so k by I, this is positive, so we'll keep minus sign, and this is 1.2 j. Now k cross product j, this is minus, and we have minus, then we have positive 1.2 I. So as we expect that VC has two components, one in the positive I direction and one in the negative j direction. So 1.2 I minus 1.2 j. Okay. Okay. So now let's move to the acceleration equation for this thing. So we could find the first unknown, which is VC. Now AC is equal to AA plus the tangential relative acceleration equation, which is alpha cross product R C with respect to A minus omega squared, obviously, dot product R C with respect to A. Now, acceleration A is unknown, is 0, sorry, and this is equal to alpha is given to be 4 rad per second clockwise, so this is minus 4k because it's clockwise. Cross product will travel from A to C as in the previous scenario, so traveling from A to C means we'll go in point 4 I direction, and then we'll go in the positive point 4 J direction. Minus omega is given to be 3 squared is 9, and no need to substitute direction because this is squared. Okay. Dot product 0.4 I plus 0.4 J. Okay. Now AC is equal to K cross product I. This is positive, so negative. We have negative outside, so negative 1.6 in the J direction. Now K cross product J, this is negative, we have negative, then positive 1.6 I. Okay, and the rest is the direction for the rest is as is. So minus 9 multiplied by 0.4 is minus 3.6 in the I direction, minus 3.6 in the J direction. So simple addition now. So AC is equal to, so we have minus J minus 1.6 minus 3.6 in the J direction, so this is minus 5.2 in the J direction. Okay, and we have 1.6 at minus 3.6, so this gives us minus 2 in the I direction. So these are the unknowns for link AC. We have two unknowns, BC and AC, so we can get them easy. Now we'll move to the other link, which is link I'll name it as is, link D E. Okay, link D E. But I will not draw the whole link. I will draw it until the corner in the slider. Okay, so here is the slider C, and here is D. So the slider is freely sliding on this link. Now we need to write the equation. So VC is equal to VD plus, instead of writing the new symbol, I will write the omega cross product RC with respect to D, and here's the new component, which is VC with respect to D. Okay. Now VC, we could find it in the previous solution, which is 1.2 in the positive I direction minus 1.2 in the negative J direction, and this is equal, VD is constant, is fixed, so it is 0, plus omega will assume it to rotate in this direction, so it is clockwise, so minus omega K direction cross product. Now we'll move from D to C, we'll move completely horizontally, so this is 0.4 in the I direction, positive I direction. Now VC with respect to D will assume this, because we'll move from here to there, so this is the relative velocity equation, so this is VCD. Okay, so we'll choose its direction to be positive, so this is VCD in the positive I direction. Now let's do the cross product. Then this is K cross product I, this is J, so we have minus 0.4 omega j direction plus VC with respect to D. This is in I direction. So now we have two equations with two unknowns. I equation, we have 1.2 in the left side, and in the right side we have VC with respect to D. So this is the direction and magnitude of VC. It is correct from D to C in the I direction, and its value is 1.2 meter per second. Now for the J equation, we have minus 1.2 in the left side, and on the right side we have minus 0.4 omega. Then omega will equal positive, which is equal to 3 rad per second. Okay, so and we assume it clockwise, so it is clockwise. Okay, so its direction is clockwise. So we could find the first unknown for this problem. Okay, so the first unknown is 3 rad per second. Now let's move to the new equation, which is acceleration equation for this length. Okay, so the acceleration for this length, which is a little bit long, AC is equal to AD plus alpha cross product RC with respect to D, okay, minus omega squared multiplied by RC to D. Okay, so if you go back to the slide, then this is AC, AD, this is alpha cross product RC to D. This bracket I can convert it to minus omega squared RC to D. Okay, this is why I write omega C to D minus omega squared RC to D. Now plus 2 omega CD force cross product VC with respect to D plus acceleration AC with respect to D. Now AD is 0. AC we could find it in the previous length, which is equal to minus 2 in the I direction, minus 5.2 in the J direction, and this is equal alpha. Let us assume that it is clockwise again, like omega. So I would write minus omega in the K direction, cross product, moving from D to C again, completely horizontal in positive direction, so positive 4 in the I direction, minus omega, we could find it in the previous solution, velocity equation, so it is 9 dot product 0.4 in the I direction plus 2 multiplied by we find it is 3 clockwise, so I will substitute omega 3 minus 3k cross product VCD. We could find it again positive quantity, which is 1.2 in the I direction, positive I direction, plus acceleration ACD, and we'll assume it again in the positive I direction. So both VC with respect to D and AC with respect to D, always we assume it flow with the link. Okay, so let's write them again. So I'll use another color, get confused. So minus 2 in the I direction minus 5.2 in the j direction, which is equal to k cross product I. This is positive quantity. Then we have minus zero point 0.4 omega j. Okay, so now minus 9 multiplied by zero point 0.4, this is 3.6 minus 3.6 in the I direction. Now 2 multiplied by 3, this is minus 6. K cross product I, this is positive j. Then this is minus 7.2 in the j direction. Okay, plus AC with respect to D in the I direction. So here in this equation, you can tell easily that we have only two unknowns. So we'll start with the J equation because we care only about alpha. No need to find AC with respect to D, but if you find it, it will be good. So starting with the J equation, in the left side we have minus 5.2, and on the right side we have minus 0.4 alpha and minus 7.2. Okay, so put alpha in one side and everything else in the other side. So 7.2 minus 5.2 divided by minus 0.4, and this gives, of course, minus sign, but let me calculate the value. It will be 5, so minus 5 rad, and the minus sign means that the assumed direction clockwise is wrong and we need to opposite the direction. So yes, minus 5 rad per second, this is the answer. Okay, but the direction assumed is incorrect. So we end up with only one problem. So next lecture I'll solve it. Okay, and continue our course inshallah. Till then, see you soon and stay safe.